Good day, class. My name again is John Obodo. We'll be looking at the term calculus. And in this, we have talked about in earlier class, introduction to calculus, where we talked about first principles and the application of first principle. Here, we want to look at the further aspect of it, where we apply what we call formula method of differentiating. And we look at function of a function, product rule, and quotient rule. Okay, so here I want to look at the term differentiation using formula method. So when we differentiate using formula method, there are a lot of things we need to understand from that. And using formula method, differentiation becomes much more easier. Okay, so we look at a given function, y equal to x squared. We used the first principle to differentiate this in our previous lessons, and we're able to establish that the differentiation of this, which is y plus delta y, is equal to x plus delta x all squared. And when we expand this, we have x squared plus 2x delta x plus delta x all squared. Okay, so we can say that y, that is delta y, is equal to x squared plus 2x delta x plus delta x squared minus y. Well, we have the y here. So delta y is equal to x squared plus 2x delta x plus delta x squared minus x squared. So x squared, we cancel out x squared. And if x squared cancel out x squared, we can further say that delta y is equal to 2x delta x plus delta x squared. If we divide both sides by delta x, we have delta x cancelling out this, and delta x cancelling out this, and delta x here. So this cancel out this, we cancel one of this. So therefore, what we have is delta y divided by delta x is equal to 2x plus delta x. And as delta x approaches 0, delta y over delta x approaches dy over dx. Therefore, dy over dx is equal to 2x plus 0. So the answer is 2x. So this is to for us to see how, or what we did in the last class, where we talked about differentiation using the first principle method. But if we want to use the formula method, we consider if y is equal to ax raised to the power of n. I want to differentiate this. For us to differentiate this, we can say dy over dx is equal to n ax n minus 1. So we have the formula given as this. That means we can solve the same problem we just solved now. If this is similar to this and want to differentiate this, we can say dy over dx is equal to 2x 2 minus 1. And that is equal to 2x as the final answer. Remember that if we say y equal to x squared, there is an invisible 1 here. And this is equivalent to ax raised to the power of n, where a equal to 1, x is the x represented, and n equal to 2. So by the time we apply this formula, we can solve any function given in form of x and y variables. So therefore, we can further simplify or differentiate a polynomial. So how do you differentiate a polynomial? To differentiate a polynomial, let's write differentiation of polynomials. Differentiation of polynomials. Now, to differentiate a polynomial, what is a polynomial? A polynomial is a function or a mathematical expression in the form ax raised to the power of n plus bx raised to the power of n minus 1 plus cx raised to the power of n minus 2, and so on and so forth. So therefore, we can have a simple polynomial y equal to 2x squared plus 3x minus 1 is an example of a polynomial. So for us to do this, we need to differentiate using the formula method or technique. We say dy over dx is equal to 4x plus 3 minus 0. Because 1 there is a constant. When we differentiate a constant, it will give us 0, irrespective of the magnitude of the number. So therefore, dy over dx is equal to 4x plus 3. Okay, so if we are given a particular polynomial, okay, from here we have the rules of differentiation. We'll differentiate the constant, and we have 0. That is the procedure for doing that. And we're on differentiation of polynomials. So we can have different types of polynomials as we have earlier. So we can differentiate them using formula technique. So let's move along. As we see other examples, we have y equal to x cubed plus 4x raised to the power of 2 minus 3x plus 1. If you differentiate this, we have dy over dx is equal to 3x squared plus 8x minus 3. If you differentiate this, you have 1 or 0. So we have 3x squared plus 8x minus 3 as the answer. If you're also given another form of function, y equal to formula method of solving. So right now, I want to look at other techniques of differentiating a particular function, especially when we have a relationship between two functions, where we talk about what we call function of a function. So how do you deal with terms that have function of a function? When you are given something like y is equal to f of g of x. F of g of x becomes a function of a function. We call it function of function. I'm going to look at examples on that. We're given y equal to 2x plus 1 raised to the power of 2. How do you solve this? For us to solve this, we represent what we have inside with a variable. Let's assume that we say let u equal to 2x plus 1. Let u equal to 2x plus 1. Therefore, y equal to u squared. So we differentiate y with respect to u. That is, we say dy over du is equal to 2u. And that is the same thing as 2 in brackets, 2x plus 1. Okay? And we also differentiate u. Since u is equal to 2x plus 1, then we can say that u du over dx is equal to 2. So therefore, by the concept of a function principle, which is called chain rule, using chain rule, that's what we call chain rule. By chain rule, we say dy over dx is equal to dy over du multiplied by du over dx. Okay? dy over du is this, and du over dx is this. So when we differentiate, we say dy over dx equal to dy du, which is 2 in brackets, 2x plus 1 multiplied by 2. So finally, the answer there will give us 4 in brackets, 2x plus 1. Okay, so that is a differentiation using chain rule, or what we call function of a function. So differentiation using function of a function or chain rule method is very, very important in dealing with functions that have very high exponentials or exponents. We can look at another example of such when we are given y equal to 3x squared minus 4x minus 6 all raised to the power of 3. And you ask to find dy dx. How do you find dy dx? To find dy dx, we say dy dx is question mark. Or we say let u equal to 3x squared minus 4x minus 6. So du dx is equal to 6x minus 4 plus 0. And that is du dx. And we know that y expressed as a function of u is given as y equal to u raised to the power of 3. So dy du is equal to 3u squared. And that is 3 in brackets, 3x minus 4 minus 6 raised to the power of 2. Okay? So therefore, dy over dx is equal to dy over du multiplied by du over dx. And dy over du is equal to 6x minus 4. And du dx is equal to 3 in brackets, 3x minus 4x minus 6 raised to the power of 2. So the final answer here, we can bring this forward. We have 3 in brackets, 6x minus 4, bracket open, 3x minus 4x. Remember there is a square here, okay, minus 6 all raised to the power of 2. So you can open a bracket. We have 18x minus 12, close brackets, then 3x squared minus 4x minus 6 all squared. So we have this as the answer to that expression. So you can solve another problem related to that. I'll just give you this following exercise. Using what we call the chain rule, you can solve this one. Y equal to 3x squared minus 4 raised to the power of 4. And the second one, y equal to 2x plus 5 raised to the power of 8. You can solve these two under this aspect of what we call chain rule. So use that to solve that. So we look at the next item we have there. The next item we have there has to do with what we call the product rule. And what is this product rule? The product rule is another rule that is used in differentiation. When we apply the product rule to solve problem, we look at how we can differentiate two products with different, what's it called? Different terms, then arriving at the final answer. So using the product rule, how do we get this product rule? We have this, y is equal to uv as product rule. We want to use product rule to solve problem of this nature. When you are given y equal to uv, how will you differentiate this? Now, we can prove this quickly and say, since y equal to uv, let us use what we call the first principle to prove that using the product rule, we can differentiate a product function. For example, y equal to uv, what we do is say y plus delta y is equal to u plus delta u. Okay? Bracket open, bracket close, v plus delta v. Okay? So we can now say delta y is equal to u plus delta u, open bracket, v plus delta v, minus y. Y is uv. Okay, so we have delta y equal to, you can open the bracket, uv plus u delta v plus v delta u plus delta u delta v minus uv. And we know that uv is appearing here, so uv we cancel out uv. uv cancel out uv, so we have u delta v plus v delta u plus delta u delta v is equal to, in the left-hand side, delta y. So with this, we can divide through with delta x. So let's divide through with delta x. Okay, so when we divide through with delta x, we say delta y divided by delta x is equal to u delta v divided by delta x plus v delta u divided by delta x plus delta u delta v divided by delta x. Okay, so at this point, we can say as delta x approaches 0, as delta x approaches 0, then we say that delta y divided by delta x approaches dy over dx. Delta u over delta x approaches du over dx. And delta v over delta x approaches dv over dx. So when this occurs, we cannot get the answer to this. And therefore, we say that delta u delta v divided by delta x will be equal to 0. So therefore, what we have is dy over dx is equal to u dv dx. And dv dx here is this, that is dv dx plus v du dx, which is this, that is du over dx. So with this, we have derived the equation for what we call the product rule. And we are differentiating or given y equal to uv, dy dx is u dv dx plus v du dx. Or what we say, you differentiate one, leave the other, and differentiate the other and leave the one by adding the two functions together. So we are going to look at an example on that and see how it's going to pan out as we solve a problem relating to a product. So we are given this y equal to 2x plus 1, all right, brackets. We have x plus 2 raised to the power of 2. So how do you solve this? Using the product rule. So using the product rule, we want to solve this, we apply the y equal to uv. Here, u equal to 2x plus 1 and v equal to x plus 2, all squared. Okay, so how do we solve? We differentiate this. Du dx equal to 2. Okay, and when we differentiate this, dv over dx is equal to 2 in brackets x plus 2. 2 in bracket x plus 2. Since the coefficient here is 1, so there is only using a chain rule to solve that. So we have gotten their various differentiation. So we say dy over dx is equal to u dv over dx plus v du over dx. And u here is 2x plus 1. U is 2x plus 1. Bracket dv dx. We look at dv dx. dv dx is 2 in brackets x plus 2. Close the bracket. Then plus v. Our v here is x plus 2 all squared. And x plus 2 all squared, du dx is 2x plus 1. So we have 2x plus 1. So we simplify it. When we simplify, 2 is common here. We have 2 in brackets. 2x plus 1 and x plus 2, close the big bracket, plus another big bracket, x plus 2 all squared, 2x plus 1, close bracket. Now look at the two terms. We can see whether something is common among them. So we have 2x plus 1 is here and 2x plus 1 is here. X plus 2 is here, x plus 2 is here. So we can bring out those terms and say 2 in bracket, 2x plus 1, close bracket, open another bracket, x plus 2, close the bracket, open a bigger bracket. We have 1 here, 1. Plus, we have this term here will disappear, so we have a smaller bracket. Okay, we can just say x plus 2, close brackets, so close it. So we simplify that, and that will give us 2 in bracket, 2x plus 1, x plus 2, 1 plus this will give us 3. So we have x plus 3. So with this, we have gotten to the end of the answer, and that is the answer to the differentiation of this. So using product rule can sometimes be cumbersome when you are solving a particular problem. So you need to be a little bit slow and steady with it, otherwise you'll miss the steps. So it's very important when you are using the product rule to solve a vulgar problem or fraction, you need to be a little bit slow and steady. Okay, so that is the solution to y equal to 2x plus 1, in bracket, close bracket, open, x plus 2, close bracket, all squared. And this is our solution. So with this, we can move on to what we call the quotient rule. The quotient rule of solving a differential problem of differentiating. And what is this quotient rule all about? We are going to look at this quotient rule and solve some other problems under differential calculus. We are given y equal to u over v. For us to derive the quotient rule, okay, we have to prove. We want to prove that dy over dx is equal to v du over dx minus u dv over dx divided by v squared. So how do we prove this? Using what we have here. So from here, y equal to u over v. This is something as saying, you can say y plus delta y is equal to u plus delta u divided by v plus delta v. Okay, so delta y is equal to u plus delta u divided by v plus delta v minus u over v. Okay, so when we solve further, we can simplify, find the LCM of the denominators. So delta y is equal to, LCM is v in brackets, v plus delta v close bracket. So this cancel out that. So we have v in brackets, u plus delta u close minus u in brackets. This we cancel out this, and that we have v plus delta v. Okay, when we simplify this further, we can open the brackets. We have uv plus v delta u minus uv minus u delta v. So this and this we cancel out. Remember that we have v in bracket v plus delta v. Okay, so we have the expression changes to v delta u minus u delta v over v in bracket v plus delta v into the y. When we divide both sides by delta x, we have delta y over delta x is equal to 1 over delta x in brackets v delta u minus u delta v divided by v in bracket v plus delta v close bracket. So we open the bracket, we have v delta u all over delta x minus u delta v divided by delta x all over v in bracket v plus delta v. So we now find the limit of this expression. So we find the limits. We said limit delta x approaching 0. Delta x approaching 0, that means delta y over delta x will approach dy over dx. Okay, and delta u over delta x approaches du over dx, and delta v, okay, divided by delta v over delta x approaches dv over dx. So therefore, if that is possible, we can now say that therefore dy over dx is equal to v du over dx minus u dv over dx, all divided by v squared. So we have this as the expression. Now, recall that what we have there, here, we have delta v when we expand this, but delta v will also approach 0 here. So therefore, we have v squared. V multiplied v will give us the answer there. So we can solve problems using what we have here. And we can rewrite the expression for this, and we can have it as v u prime minus u v prime divided by v squared. That's another form or way of writing the quotient rule. So we are given this problem, y equal to root x divided by x plus 1. And if we have to solve this problem, we need to make this u and this v. So therefore, we are given u equal to root x, therefore du over dx, which is equal to u prime. That is differentiation of u is, this is something as x raised to the power of half. So you have half x half minus 1, and that is half x minus half, which is something as writing 1 over 2 root x. Okay, so that is a u prime, or differentiation of u. And v is equal to x plus 1. So if v is x plus 1, dv divided by dx, or dv dx, is equal to, if you differentiate this, you have 1. So using your quotient rule again, we have dy over dx is equal to v u prime minus u v prime over v squared. So we substitute. V here is x plus 1. So v is x plus 1. So we have x plus 1. U prime is 1 over 2 root x minus u. Our u here is root x, which is this. In brackets, v prime. V prime is 1. So we have 1 divided by v squared. V squared is x plus 1 all squared. So when we simplify that, we have x plus 1 divided by 2 root x minus root x all divided by x plus 1 all squared. So with this, we can simplify further, and we have this as the LCM, 2 root x. We have x plus 1 minus root x multiply 2 root x, close the bracket, divided by x plus 1 all squared. So when we do further simplification, this multiply this with 2x. We have 2x. We have x plus 1 minus 2x minus 2x, okay, divided by 2 root x in bracket x plus 1 all squared. So that is equal to minus x, okay, you can say 1 minus x, 2 root x in bracket x plus 1 squared. So this is the answer to the differentiation of this expression. We can solve other related problems, very simple ones. Quickly, we have y equal to x plus 1 over x minus 1. To differentiate this, we make this also u over v. U prime is 1, and v prime is 1. Recall that u equal to x plus 1, and v equal to x minus 1. So when we simplify this, simplifying this using your quotient through dy dx is equal to v u prime minus u v prime divided by v squared. So we substitute. V is x minus 1. So we have x minus 1, u prime is 1, minus u. U is x plus 1, x plus 1, multiply v prime. V prime is 1 here. So we have v squared is x minus 1 squared. So simplify. We have x minus 1 minus x